Hi students, this is Alex here. In this video, we are going to find the Fourier series for the given function f of x. As a first part, we are going to write the formula for the Fourier series, which is f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Now a naught is 1 by pi integral 0 to 2 pi f of x dx, and this is 1 by pi integral. We have function as a two part, so one is from 0 to pi and the function is minus a, and second part is again we have to write 1 by pi integral pi to 2 pi and a dx. Now coming to the integration, we have minus a, its integration is minus a x, limit is from 0 to pi, and again this is 1 by pi, a integration is ax, limit is from pi to 2 pi. We are going to substitute upper limit then minus lower limit. When I put upper limit minus a pi, this is upper limit. When I put lower limit, it becomes 0. Similarly, when I use upper limit, this is a into 2 pi minus a into pi. So this is minus a pi by pi is the first term, and second term is 1 by pi. This is 2 a pi minus a pi is a pi. So we can see both gets cancelled, but before that we can cancel these two, and we have minus a plus a, and finally a naught value is 0. Coming to an, formula is 1 by pi integral 0 to 2 pi f of x cos nx dx, and again we are going to substitute f of x. F of x is made up of two parts, so we take 0 to pi minus a into cos nx dx is the first part, again 1 by pi integral pi to 2 pi a into cos nx dx. Now this a can be taken out, so a by pi integration of cos nx is sin nx by n, and limit is from 0 to pi. In the same way, when a is taken out, a by pi, we have cos integration which is sin nx by n, and limit is from pi to 2 pi. When I put upper limit, we get sin n into 2 pi by n minus sin 0 is 0. Similarly, this becomes, sorry, here it is only pi, upper limit is pi, so sin n pi. Similarly, here it is sin n 2 pi by n minus sin n pi by n, and sin n pi is 0 and sin n into 2 pi is also 0. So everything's become 0. Finally, an becomes 0. Now bn, by formula 1 by pi integral 0 to 2 pi f of x into sin nx dx. So again we take interval only from 0 to pi, f of x is minus a, then sin nx dx, and again this is 1 by pi integral pi to 2 pi, it is a into sin nx dx. Now coming to this integration, we can take minus a common, so minus a by pi, Sin x integration is minus cos nx by n, 0 to pi, and this is a by pi minus cos nx by n, and pi to 2 pi. Now minus a by pi, when I put limit, minus cos n into pi, so cos n pi by n minus cos 0 by n, so upper limit minus lower limit, plus again a by pi is outside, when I put 2 pi cos n into 2 pi by n minus, when I put lower limit, minus cos n into pi by n. Now cos n pi value is minus 1 whole power n, and cos n into 2 pi is 1. So first part minus a by pi, this is minus of minus 1 whole power n, and this will become plus 1, and we can make a common denominator n. In the same way, second part is a by pi, and this is 1, but already there is a minus 1, so minus 1 plus, we can cancel these two, so we can make this as plus, and here this is minus 1 first part, and this is minus 1 whole power n, and we can make a common denominator n. Now we can take this minus inside of this, so a by pi, when I take minus inside, this becomes minus 1 whole power n, then minus 1 whole divided by n. And here we write as it is, but the thing is, we take the positive term first, then we take the negative term. So we can find these two terms are same. So when we add, we get 2 times of a by pi, and n we can keep it here, and we have minus 1 whole power n, then minus 1. Now when I take, if n is even, then what happens is bn equal to, when this is even, minus 1 whole power any even number like 2, 4, everything, this will become 1, and 1 minus 1, that gives 0. Suppose if n is odd, then bn becomes minus 1 whole power any odd number will give minus 1. So minus 1, then minus 1 is minus 2. So already we have 2a by pi n into minus 2. So totally bn is minus 4a by pi n when n is odd. Now coming to our Fourier series formula, f of x, the first term is a naught by 2 and sigma n equal to 1 to infinity a n cos nx, but we got a naught as 0 and even a n as 0, and first two terms will not be there. So coming to the third term, summation n equal to 1 to infinity, but here we find it exists only for the odd, for even it is 0. So we take, when n is odd to infinity, f of x, which is minus 4, sorry, bn, which is minus 4a by pi n into sin n x. So here we can take the constants minus 4a by pi outside. Now summation n equal to odd to infinity, and we get sin nx by n. So this is the required Fourier series for the given function f of x.